Okay, this is what our last thing we did, displacement meters. Okay. So attempt the test without fail. I kept 60 minutes. Okay, because you have to solve few questions. It will take time. So I gave like 4 minutes. Actually, it should be 3 minutes only, but I gave 4 minutes for each. Check your timer. We should track timing, okay? Don't forget. Track timing, like how much time you spend for each question. There are 15 questions. Yeah. And these are not like JEE questions, so it won't be that much hard, but it will be a little bit calculative. I need to think. This of practice question. JEE question, we'll do it here. Okay, so need not to tell you, turn on your camera. Let's start. Okay. Aditi, Samhita. And only 5 others didn't join. Okay, them join. Okay, what's acceleration now? Do you remember?
The rate of change of velocity.
The rate of change. The rate of change of velocity. That means rate means with respect to time. Now about this, it is vector quantity. It is vector quantity. Now, so here what we are considering, change in velocity with respect to time. Change in velocity with respect to time. That is delta t. Average acceleration is given by AV vector delta V by delta t. So this is your average acceleration. Now, if I want instantaneous, then what is instantaneous acceleration?
dv by d. No. Velocity by time.
Yeah, it's dv by dt, correct. Here, this is average acceleration. We'll find some average value of v and by t. So instantaneous means dv by dt. Limit, excuse me, 10 to 0. delta v dash v bar by v t equals to dv by dt. Is time a vector quantity or scalar quantity?
Scalar.
Okay. So velocity is vector quantity, right?
Yes, sir.
So acceleration is dv by dt. This is instantaneous. What will be the units?
Meters per second square.
Yeah, meter per second square. This is your SI unit. And what about CGS unit? CGS unit will be
M0 L1 T minus 1.
no, that is dimensional formula.
Centimeter per second square.
Yeah, centimeter per second square. Dimensional formula is M0 L1 T minus 2. These are dimension. Units is this it's quantity like meter per second. Quantity of those units. They have like units for quantity. This m is the mass. Mass as quantity, kg. So you will write unit as kilogram. So unit are those things which represent quantity. Okay, suppose if body is moving with uniform velocity, so what will be acceleration?
0.
0. What does it means? If it is uniform acceleration, zero velocity, sorry, uniform velocity and zero acceleration, what does it means? It has no speed, not even direction. So it has, or it does not have speed and direction. direction of motion. Okay. So next is uniform acceleration. See, we saw uniform velocity means acceleration is 0, but if acceleration is uniform, what does it mean? What does it mean when we say uniform acceleration? We saw uniform velocity means 0 acceleration. Now we are keeping acceleration as uniform. Now what does it represent?
Projectile motion.
Projectile motion. Okay. Now what
Body.
is body is what?
When a body is uniformly accelerating with respect to time, as in it's changing its acceleration uniformly.
Okay. Okay. Any other? Anything else you want to add?
The velocity increases constantly.
Velocity increase constantly. Okay. Some more points. Anyone? Okay then. It means like, yeah, a velocity change, velocity of body changes equal amount in same interval, same time interval. So we can say body is uniformly accelerated. So when acceleration uniform, that time like we don't have like direction as well as magnitude. So we are not representing here direction. Or let's write this way. Neither direction nor magnitude. Changes with respect to so neither direction nor magnitude changes with respect to time.
So then I have a doubt.
Yeah.
So how is it uniform? How is it acceleration? Because acceleration is change of velocity.
So direction is not changing. It's moving in same way. Like it's actually we can say a speed. So uniform accelerated means it is changing uniformly. This velocity is changing uniformly of a body with respect to time. Now, when we talk about uniform velocity, it is like uniform motion. It's related to uniform motion. It is uniform velocity when like object is changing with respect to time. Object is positioning with respect to time. Now, in uniform acceleration, it is that what we said before, like a uniform velocity. So that same thing here, uniform velocity with time. That is uniform acceleration. In uniform velocity, we said changing of motion with the same interval. So we are just adding one more interval here. That means velocity is changing with the same interval of time. So first we saw like distance, changing in distance, equal distance in equal time. It gives you velocity, uniform velocity or uniform speed. Now changing velocity with respect to same time interval give you uniform acceleration. That is what a uniform. So it is moving, but we are not worrying about the direction here. It's neither direction or magnitude change. So it is fixed value. It is like not increasing, not decreasing. It is now fixed value. So magnitude is not changing. Acceleration magnitude. Okay, I'm not talking about velocity magnitude. We are talking about acceleration. Means that ratio v by t will remain constant. That's what it means. Neither direction or magnitude change with respect to time. That's what uniform acceleration means. Okay.
Yes, sir.
Now, if I say like non-uniform or variable, now in this one, totally opposite of this one, a previous one. Velocity of body changes in different amount during same time interval. Same thing I'm writing from the above. So we can say it is non-uniform motion or sorry, acceleration or variable acceleration. Now in this case, either direction or magnitude or both changes with respect to now. Can you give me example for this one? Where direction is also changing and magnitude is also changing.
Circular motion.
Exactly. In circular motion, if you observe here from its direction is keep on changing. So we can write here example. Then what will be previous example? Like previous case example when there is a uniform. Yeah.
Projectile.
Projectile. But projectile also is changing direction, right?
Horizontal motion.
Or linear motion.
Yes.
Okay, let's draw a graph for this. Okay. So first graph will draw like when it's the same as usual. Time axis will be x axis and y axis will be acceleration axis. When a is 0. So how to draw a equals to 0?
A constant velocity by time.
At 0th position, a is 0. If the motion is in this direction, so we can say a is
At
0.
the origin.
Yeah, origin. Time axis. Now second one, acceleration is constant. How to represent acceleration constant?
A straight line.
Straight line. So it will be like this is your is constant. When acceleration is increasing and in positive. So how to draw this one? It is increasing and it's positive.
The straight line is sort of going upwards.
Upward. Yeah. This is your increasing. And if I ask you decreasing, reverse of this one.
Yes, sir.
Time axis. Draw for decreasing in negative direction.
It will be a mirror image of the.
Yeah, mirror image. Decreasing and is negative. In this direction, time axis, This is decreasing. Decreasing spelling. Now, if I want to show non-uniform motion, but initially 0, so I want to start from 0. It's when it is also very simple. Just starting from 0 can be any shape. Time axis. Change in velocity of is equals to same as usual what we wrote for velocities. That's what we are writing. Enclosed by change in velocity. For that, we need what? Area under curve. So you drawn all this graph, or shall I show you from the beginning?
Done, sir.
Everyone?
So 1 second.
Sure.
Good answer.
Okay. Okay. So what are 3 equations of motion? Do you know? Remember?
Yes, sir. S is equal to ut plus half at square. V square is equal to u square minus 2as. V is equal to u plus at.
Okay. And if I want in vector form, then same thing, nothing big here. Wherever we have vector quantity, we will just put vector.
Yes, sir.
Okay. I posted one more time message, but that's it. Okay. Equation of motion. Or this can be, we can say that uniformly accelerated motion. We are studying uniformly accelerated motion. When, what is uniformly accelerated motion? When we have magnitude and direction constant.
Constant.
So this chapter is totally about uniformly accelerated motion. First one, you know, v equals to u plus at. So if you want to write vector form, v vector equals to u vector plus
A vector t.
t. Tell me second equation.
V square vector is equal to u vector plus sorry. V square vector is equal to u square vector minus 2a vector s
Plus 2as.
vector.
Yeah. Vector u square plus 2a vector. What about s?
Vector.
Yes. And another equation.
S vector is equal to u vector into t plus half a vector into t square.
Oh, sorry. Fourth equation. Do we have fourth equation?
Maybe with downward acceleration.
Nahi.
I don't know.
Average. So same way we can write here as
Vector is equal to u vector plus v vector.
into time. Average. Fifth equation. Do we have fifth equation?
I don't know, sir.
It's similar to this one, previous one. This is for distance travel in and second.
Oh yes, sir, but I forgot. What it
Yeah,
was.
Sn equals to u plus a by 2, 2n minus 1. Similar way, if we want in vector form, let it be same. Okay. So wrote all these equations.
Yes, sir.
Everyone.
Yes.
Garima,
Yes, so done.
Samhita,
Yes, sir.
Done?
Yes, sir.
ठीक है. Am I going fast or it's slow?
It's good, sir.
Okay. If you feel like I'm going fast or I'm going slow, you can tell me. Okay. Now this tabular column will just for like understanding whatever we discussed till now. So it is overall thing. Like when displacement S, here we are taking displacement as S, is given as a function of time. T equals to function of time T. Let's write this here. S equals to F of T. So S is directly proportional to T at 0th. That means body at rest. That means V equals to 0, A equals to 0. You can write this in tabular column so that it will be easier. I'll just make it after this. S is directly proportional T to 1. It is uniform velocity. Acceleration is 0. Therefore, V is proportional to T equals to 0. And A is 0. When S is proportional to T to 1 power 2, it is the uniform acceleration.
Accelerate.
V is proportional T to 1, A is proportional to T. 0. When S is proportional T to power 3 or more, this is just for understanding. We will not use those things here. We'll directly use like integration, differentiation, whichever required. This is just for like non-uniform acceleration at V is 2. Or next will be keep on more, or we can write here or more. Same way, A is proportional to T to power 1 or more. Same. So for finding displacement, velocity, acceleration as a time function, we will do differentiation or integration as per the requirement.
Done, sir.
Done? Okay.
Done, sir.
So could you scroll up once?
Sure, sure.
Before S. Yes, sir. Can you scroll more? Okay. None, sir.
Okay. Now, how you are going to use similar way, v equals to ds by dt. If you want to find s, we will do integration of v dt. Okay, this is just a formula how we are going to use and what is the requirement. That's why I'm giving you here. This all if it is a function of t. Okay, understand this, it is a function of t. Displacement, this velocity, and next is our acceleration. So a is dv by dt. This is also function of t. Then we will do this way. Then if we want to find v from this equation, integrate a with respect to time. So this all are function of t. Let me write here. Displacement, velocity, acceleration, as a function of time. But when a equals to function of s, that means displacement, then we need to do double differentiation or different way we have to do. So what we'll do here, I'll just write directly here. A v dv by ds.
dt, ds.
How we are getting this? It's not required, but I'll show you here because you will get confused. So we need here dv by dt because acceleration is dv by dt. Now, if I multiply and divide ds by ds, so I'll get dv by ds and ds by dt. So ds by dt is v. Just now we wrote, right? So what we'll do here, we will just multiply v here and we'll differentiate v with respect to s in this one. Understood? In a note, you can write this one inside so that you'll remember later on. Now you'll remember, but then you'll forget. So make a note of this, like inside as a rough column or somewhere, or as a note.
Done, sir.
Sir, can you scroll up?
Sure.
Okay, done. Sir.
Now, if I want to find like a value or dv value, so what we'll do here? Integrate here. A ds equals to v dv. Integration. Okay. All these have same notation. Okay, like displacement. Now here A is instantaneous acceleration. V is instantaneous,
Velocity.
yeah, velocity. So overall, what we discussed today. See, let's summarize this so that you will not forget. We should not forget this. What we discussed today. Come on, summarize this fast.
Acceleration.
Okay.
Its graphs and then the differentiation and integration part of it.
Okay. Anything else?
Equations of motion.
Function.
No, I said equations of motion.
Equation of motion. Equation of motion.
Yeah.
Okay. Yeah, equation of motion. So let's summarize this. How we started first.
Acceleration.
Motion of body. What is our starting? Okay. And this one, uniform, non-uniform, is graphs, and this forms. Okay. See, remember this mind map? It's enough. I'll make just one mind map here. Excuse me. So like for a board exam or something like that exam, so after you finish a chapter, this mind map will be helpful for a board exam, but formula book will be helpful for your like a public exam, competitive exam. I mean. Okay, so first we saw velocity constant, previous class, right? So it is velocity is displacement by time. Now we move, that means we have accelerated motion. In accelerated motion, let's see how many points we had. Uniformly, non-uniformly. Accelerated and non-uniformly. For uniformly accelerated motion, we had some formulas. V equals to U plus AT, S equals to UT plus half AT square, V square minus U square equals to 2AS. And what we wrote here, nth, right? S nth equals to U plus A by 2, 2n minus 1. S equals to half U plus V into T. This is all we studied for uniformly accelerated motion. Non-uniform, we saw V equals to ds by dt, A equals to dv by dt, or V ds by, sorry, dv by ds, right? dv by ds. So this is all we did today. Now one more easy way we can make this one as like a displacement to velocity we can go, from velocity to we can go acceleration. So here we will differentiate. Now if you want reverse, we will integrate. Here also differentiation, integration. So let's write this one here itself. Differentiation we wrote v ds by dt. Here a dv by dt or v dv by ds. Now integration, what formula we wrote? Reverse of this one. With dt. Or another formula we wrote, same we can write a ds v dv. Okay, see, done this one?
Yes, sir.
Yes.
1 minute.
Okay. Now see, we said here non-uniformly accelerated motion, so we are using these formulas. Now it is not necessary that we will use only for this. Okay, if we require, we can use there also. If they give an equation form, they're not giving direct. So we have to use it. And we will get answer as uniform. So it's not like that we have to use only for non-uniformly accelerated motion. Okay, so just for all this, what we wrote, so no need to do this janjat. Okay, just remember this box. I think so this will be enough. It will cover everything. Let's make it one big box. Okay, remember this box, it's more than enough. I think so we got all the formulas in this one, right? Displacement, velocity, VDS, VDT, velocity to acceleration, yeah. And yeah, I think so it's all the formulas here. Any doubt in this one?
No, sir.
No, sir.
Okay. Fine, then actually